Good morning, everybody. Welcome to my question of the day, which is number 17 in a series I've been running every weekday since the beginning of September on my Facebook page. If you haven't done this problem before, it may be worth you pausing the video and having a go, and then I'll explain how I would do it. Of course, you could use trial and error. I think that would be the least satisfying way of solving this question. You could do. There's nothing stopping you from doing that. But I'm going to try and do it slightly more rigorously. I love solving equations. You may be tempted to find the value of x and the value of y and find their product in order to answer this question, but it may be that you can find the value of x, y without finding the individual values of x and y. And that's kind of the route I'm going to take through this. So I'm just going to start off by writing my equation. And again, I'm just going to say that there are a number of ways you could do this. I'm just going to show you the way that I did it. It's not necessarily the best way, it's just a way. Now, I notice that I've got fractions on both sides of my equation. Now, on the left-hand side, I think I just might combine the fractions that I can see on the left-hand side and make them into one fraction by cross-multiplying. So I've got x squared minus 1 over x, and I'm going to do the same on the right-hand side. Y squared minus 1 over y. I'm going to then get rid of all the fractions, and I'm going to do that first of all by multiplying both sides by x. So I'm going to have x squared subtract 1 on the left hand side and x lots of y squared minus 1 over y on the right hand side. To get rid of that y on the denominator of the fraction, because it means divided by y, I can easily multiply everything out by y. I'm doing the same to both sides. Y lots of x squared minus 1. I put brackets in there to just remind myself I've got to multiply every term on the left-hand side by the y, otherwise we don't keep the balance. So I've got this situation here. It's always best to solve equations by expanding brackets to start with. I've got x squared y minus y on the left-hand side and xy squared minus x on the right-hand side. Now, because I've got powers of x and y that are bigger than 1, I think that I'm going to approach solving this equation by making the right-hand side equal to 0. When I have a quadratic equation, it's always best to solve if the right hand side is equal to 0, otherwise it's just not really the way you would solve it. So I'm just going to make everything equal to 0 on the right hand side. So x squared y subtract y. I'm going to subtract xy squared from both sides and add x to both sides, and I have equals 0. I'm going to put my red arrows in there to show you that I subtracted xy squared and added x to both sides. I think it's quite useful, especially if you're starting out with algebra, to really explain what you're doing. Now I can see that I've got two terms, x squared y and xy squared, that both have an xy in common. That's quite useful. So I'm going to factorise. I suppose what I could do first is just write them next to each other. Some people prefer that. And then I've got plus x subtract y equals 0. So I've just rewritten it there. Now I'm going to factorise. And I'm going to write down that I'm going to factorise by taking out a common factor of xy. Now I won't be able to factorise everything on the left hand side, but look what happens when I do. I've got xy. Now that's going to be multiplied by x to get that first term, subtract y, plus x minus y. Now that's kind of interesting, because if I popped brackets around the x minus y at the end, I now have two other terms that both have an x minus y in common. In further maths, at AS level at least, factoring out expressions is a very nice little technique that we use a lot of the time, sometimes proof by induction. That's always a really nice reason to use this. So I'm now going to take out a factor. So now I'm going to factorise by taking out a common factor of x minus y. Put that in brackets. So I've got x minus y lots of x, y plus 1 equals 0. And that works because if you expand the brackets, you can see that it gives you exactly what I had on the previous line. Now, because these two brackets multiply together to make 0, this leads me to conclude that either x minus y must equal 0, because of course 0 multiplied by anything would give me 0, or xy plus 1 equals 0. If I follow my reasoning for x minus y equals 0, this would imply that x must be equal to y. But if I look at the beginning of the question, it tells me very clearly that x cannot equal y. So this is an invalid result. I'm going to write down since x cannot equal the value of y, which therefore leads me to conclude that xy must be equal to -1. I've done it. If I look, yes, the answer was C. Well done to those of you that gave me the solution C on my Facebook page, because I always love people to comment and leave their answers, and especially show me photographs of their methods. And there were not many people that managed to do it quite as rigorously as that. So that is what I would recommend as a good reasoning for that answer. Anyway, thanks for that. That's all for today. If you'd like to leave me a comment on my Facebook page, I would love to hear from you. And if you haven't checked out all the other questions in this series, you can check my YouTube channel. Thank you very much. Bye-bye.